Okay, here we are for question 6 of paper 1. It's a functions question, and I bet some people looked at it and said, no, that's not for me, because some people just find the functions notation, they think, it's a bit awkward looking. But I think, again, this question isn't as bad as some students might have felt at the start. What does it say here? It says the function f and g are defined as the following. F is a function such that x is mapped onto 1 minus 2x cubed, x an element of the real numbers, and g is a function such that x is mapped onto 3 over x minus 4. X is greater than 0. X is greater than 0. That's a bit of information you'd be highlighting just to make sure it might come into play. And x is an element of the real numbers. It asks us to find the inverse of this function, so f inverse. And again, this is just a small tiny part of the course, a little corner of the course. Some students might not have known it, and they'd look at this as part A and they just move on and choose another question. But if you do know it, you start off by saying, okay, your function is this. F is a function such that x is mapped onto 1 minus 2x cubed. But you can say that's equivalent to saying y is equal to 1 minus 2x cubed. And what we're going to do here is we're going to isolate the x. So we rearrange, we get 2x cubed is equal to 1 minus y, divide across by 2, get the cube root of both sides. And now I've isolated x. And we do this unusual thing here, which only happens in this particular part when you're finding the inverse function, is basically, sometimes people think about it as swapping the x and the y. But we replace x with the inverse of x, f inverse. And we replace y with x. Now, why do you do that? Well, we'll explain that another time. But that's how it works. And so you say the inverse of x, the inverse function x, is equal to 1 minus x all over 2 to the power of 1/3. And that's it. That's all you had to do for 5 marks. So again, it's not the most difficult once you know what it is. Once you know that trick. Of course, you're not going to guess that trick. You're never going to guess to replace the y with x and x with f inverse. So you have to know it. Show that the composite function g after f of f is the following. So we'll just remind ourselves what was f of x. So that was 1 minus 2x cubed. Okay. So 1 minus 2x cubed. Let me go back here. Am I right about that? I am. Okay. So what have we got? So g after f of x. So in this case, the x is the initial input. The 1 minus 2x cubed is the initial output. But that initial output becomes the input in the function g of x. So g of x, if you recall, was 3 over x minus 4. And so what I'm saying here is 1 minus 2x cubed is going to become the input in that function. So it's going to get put in place of x. So what do I do? This is what's happening. So in the place of x, I get the 1 minus 2x cubed. And now what I'm going to do is I'm going to try and reorganize what I have here to give me what I want in the question. Okay, so let's go from there. What am I going to do? Well, I'm going to get my common denominator, which is 1 minus 2x cubed. I'm going to have to multiply the minus 4 by that 1 minus 2x cubed. I'm going to multiply through the bracket. I'm going to tidy up, and I have it. 8x cubed minus 1 all over 1 minus 2x cubed. Okay, and that was a 10 marker. Okay, you have to know what to do. Again, it's not one that you're going to guess it, but I would say not too bad for 10 marks. Then solve g after f of x equals 0. Now, here's the thing. You actually had this information that g after f of x was 8x cubed minus 1 all over 1 minus 2x cubed. So you could have continued from there and gotten the answer without ever actually getting part B. So in this case, what's happening here? Well, I'm multiplying both sides by the denominator, but when I multiply 1 minus 2x cubed by 0, it's just going to disappear. So I get 8x cubed minus 1 equals 0, 8x cubed equals 1, x cubed equals 1 over 8, x is equal to the cube root of 1 over 8, x is equal to 1/2, and that was a 5 marker. Okay, so it's basically an algebra question. But now we're jumping into differentiation, to calculus. Show that the coordinates of the stationary point of this function are 0, -1. So calculus, indicating, well, in this case, differentiation. Stationary points, same as turning points. What do we know? We're going to get the first derivative and solve equal to 0. So in this case, y is equal to g after f of x, and we know that's 8x cubed minus 1 all over 1 minus 2x cubed. What do I have to do? I have to differentiate it. It's a quotient, it's a fraction, so at the top is u, the bottom is v. I'll differentiate the top. Du dx is equal to 24x squared. dv dx is minus 6x squared. Okay, and then I'm going to use my rule. It is v times du dx minus u times dv dx all over v squared. So what is that? It is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom to be squared. So, you know, it's kind of looking complicated at this point, but what we know what to do, we just multiply out the brackets, tidy it up, and we can see here these guys are going to cancel, aren't they? Minus 48x to the power of 5 plus 48x to the power of 5. So it ends up kind of nice and neat, 18x squared all over 1 minus 2x cubed to the power of 2. So it still kind of looks a bit tricky. But if we remember, of course, that how we solve it, how we get our answer is we say dy dx is equal to 0. So this part here is equal to 0. And it's actually similar to in the last part of the question. I know when I multiply both sides by my denominator, 1 minus 2x cubed to be squared, I'm going to multiply that by 0. So it's just going to disappear. So I'm going to end up with 18x squared equals 0. Divide both sides by 18, I get x squared equals 0. So x is going to be 0. Then I go back up here, put in my 0 for x, and I end up with a y value, which is minus 1. And that was a 10 marker. So again, looks like a complicated question, but overall, possibly not as hard as it looks.